Here we go. All right. Okay, so here what I'm doing is, remember, I'm just now recalling the, what do you call it? The AC method, okay? And this is another method that we can use to actually factor the polynomials, basically trinomials, as you can see there. Okay? In other words, we have seen before, here, let me do this. Here we go. So before, we've seen how to factor this, and last time I did actually show you the method, which I reproduced here. It's in the notes as well, but this is actually the method that you use for factoring this trinomial. A trinomial, excuse me, of this form, where the leading coefficient here is not 1. Where the leading coefficient is not 1. As usual, you find the GCF, and then you'll see we do some examples today. What you do is you multiply A times C, and you find two numbers whose product is that. And the sum, when you add up those two numbers, you have to get B. Then you're going to replace B in here by a sum of those factors, and then you're going to apply factor by grouping. The whole point is what you want to do is you want to convert this into factor by grouping. And let me just say this also. In the book, I think there is another method for factoring. I tried teaching it once last semester, actually, and the students weren't crazy about it, so that's why I'm not showing it now. But again, if you want to use another method in the book, that's fine. Okay. All right. All right, so let me keep going. So this is our first example today. So here, this will actually show you why it's so important to get the GCF, out first. So looking at this, as you can see, it really appears that we cannot use our method, right? And why is that? Because we have a polynomial of degree 3. Okay? We have a polynomial here of degree 3. However, though, what we can do is factor out the GCF. So let's try that. So, of course, the smallest exponent of x is 1, as we can see here. Okay? We can see that here. And now we have to consider the coefficients here. Okay, so what I did was I listed all the coefficients. I listed all the factors, as you can see. 155 is a little bit tricky, but what you can see, though, is it has 5 as a factor, mostly because the last digit here is 5. Just in case you don't know that, if a number's last digit is 0 or 5, 5 is a factor. And the other factor we get from dividing is 31. Now, even if you don't know, that is, any other factors here between 31 and 155, even it turns out there aren't any, but let's say for some reason you didn't know that, hopefully you can see that 5 is the biggest common factor among the 3. Mostly because 5 is the biggest common factor among 30 and 25. And so that kind of 4 and 5 is a factor of 155. So, not to mention also numbers bigger than 5 here, like 6, 10, 25, or any of these are factors of 155. So hopefully that makes sense what I'm trying to say. Okay. All right, so anyway, once we get that, we can see that the greatest common factor of these coefficients here is 5. So what do? Just like before, we now have the GCF, right? Our B is 5, the M is 1, so we get this. And now what do we do next? We're going to factor it out, and that's what I'm doing here. That's what I'm doing here, as you can see. Okay, let me just see something. Oh, it's not frozen. Okay, good. I wanted to make sure it wasn't frozen. All right. So that's what I'm doing again. To factor it out, you have to divide. And when you divide, you're dividing into each term here, as you can see. That's how you figure out what's left over. And so I just reproduced that here. Basically, this is what was on the previous slide, mostly because I was afraid of running out of room. And so we can see that we end up with this in parentheses. We have 6x squared minus 31x plus 5. But now you can see at least that, oh yeah, this one we can use the AC method on. So we're going to use it on this polynomial. And that's what we're going to do. So we're going to use it on this method here. Okay. So from here, let's see. Yeah, from here, hopefully you can see, even before I displayed it, that A and C are 6 and 5, respectively. Okay? We get 6 and 5, respectively. Okay, and again, B is negative 31, right? So, okay, so by our AC method, what do we want to do? We want two numbers whose product is 6 times 5, right? And the sum has to be minus 31. The sum has to be minus 31. Okay, good, good. Okay, so we have to find those numbers. So this is just writing out what I just said. Two numbers whose product is 30. The sum is negative 31. Okay, so this is what we want. And again, really just another way to visually see it, okay? What we want to do is essentially fill in the blanks here. Okay, we want to fill in the blanks. Okay, so you probably can tell already what those numbers are, but let's just go through some guesses just to illustrate the process. Okay, why don't we just do that? Okay, let me just do some first. Let me pause the recording.